Hello and welcome to Curious Minds with Mzungu Baridi. This video is again about measuring heights using shadows. The last video was about vertical objects, i.e. straight trees, etc. But what if a tree is not straight but crooked? This video deals with this and other questions. Chapter 1. Before I explain how to calculate the height of a crooked tree, I need to tell you something important about measuring. When we measure something, we always have to ask ourselves, how accurate does it need to be? Sometimes we need very precise figures. For example, when building a bridge or an aeroplane. But when we want to measure the height of a tree, it is usually enough to know the approximate height. Now comes an important question: why is a measurement sometimes not completely accurate? Is the maths perhaps wrong? No. The mathematics is correct. But in mathematics, everything is perfect. There, the ground is completely flat. The tape measure does not sag. The measuring rod is completely straight. The light always comes from the same direction. This is called laboratory conditions. In the laboratory, everything can be set up very precisely. But outside in nature, it is different. The ground may be uneven. The sand is uneven. The rod is slightly slanted. The sun moves every minute. That is why there are small differences between what we calculate and what we measure. This is called tolerance or measurement error. And that is completely normal. The important thing is that we know a measurement is never perfect, but it can be good enough for our purposes. Chapter 2. Trees often do not stand vertically in the ground, but are inclined in a certain direction. Perhaps you have already figured out how you can still measure the height? It's actually quite simple. In the picture, you can see that the highest point of the tree is above the shadow. If an object is not straight, its shadow is longer than that of your straight stick. So if you were to measure this much too long shadow, the result of your calculation would of course be that the tree is taller than it actually is. This means that you have to somehow figure out the part of the tree's shadow that is too long. In this case, you measure vertically again, but not from the trunk, but from the point below the highest point. This point is called the plumb point. From this point, we measure the length of the shadow to the tip of the shadow. Why not from the base of the trunk? Because we want to know the vertical height, not the sloping length of the trunk. We measure our stick again and calculate using the same ratio. The formula is the same as in the previous video: tree height equals stick length x measured tree shadow divided by stick shadow. This gives us the vertical height of the tree, even if it is leaning. If we want to know how long the slanted trunk really is, we also need Pythagoras' theorem, which I explain in another video. But for the height, the shadow method is usually sufficient. And now here's something amazing. 2,600 years ago, someone had the same idea. Chapter 3 hash. A Greek measures a pyramid. I have already told you about Thales. He was Greek. One day, he traveled to Egypt and stood in front of a huge structure. A pyramid. It was far too high to climb up and measure it that way. Nevertheless, he wanted to know how high it was. But how could he do that? Then he had a brilliant idea. He used the shadow. According to legend, he waited until his own shadow was as long as he was tall. At that moment, the following applied: height equals shadow length. So he just had to measure the length of the pyramid's shadow at lightning speed or with the help of an assistant. This had to be done very quickly, as the length of the shadow changes due to the changing position of the sun. Anyway, somehow he managed it. Done? Not quite. Here comes the problem. Where do you actually measure on a pyramid? At the edge? In the middle? At the top? The true height of a pyramid is measured from the center of the base to the top. But the shadow starts at the edge of the pyramid. This means that Thales had to add half the width of the pyramid to get from the edge to the center. So he probably did the following: he measured the shadow, added half the base length, and thus calculated the actual height. That was clever. The formula for this would look like this: height of pyramid equals shadow plus half width times rod length divided by rod shadow. Otherwise, he would have only measured the height from the edge, not from the center. What can we learn from this? Whether it's a leaning tree or a giant pyramid, the maths isn't the difficult part. The difficult part is measuring the right point. Knowing where to start. Keeping errors small. Science is thinking. And that's exactly what Thales did. He thought, here is another great method for measuring the height of a tree, and the great thing is that it works even when there is no sun, the stick method or arm stick method, Forester's triangles walking stick trick. All you need is a stick or broomstick and your arms. Here's how it works. Take a straight stick that is exactly as long as your outstretched arm, from your eye to your fist, usually about 60 to 80 centimeters, depending on the person. Hold the stick vertically in front of you with your arm outstretched, like a mini mast. Move forwards or backwards until the stick covers exactly the top of the tree and the base of the trunk, i.e. the lower end of the stick points to the base of the tree and the upper end points exactly to the top. Now measure the distance from the tree trunk to your feet, with steps or a tape measure. The tree height equals this distance plus your eye level, approximate 1.5 m for children and adults. For leaning trees, measure the distance to the side of the tree, not in the direction of the lean, so that the tree does not lean towards or away from you, then it will usually be spot on. Advantage: no shade required, works in any weather. Just try it out to see how accurate your measurement is and write me a comment about how accurate your measurement was. I hope you enjoyed this lecture and that it made you a little smarter. Don't forget to like the video and subscribe to the channel. If you want to support me financially, take a look at the video description, where you will find my email address. I look forward to the next video, and until then, don't forget, curiosity is the engine of knowledge.